Afternoon, ladies and gentlemen. I'm just going to go over here the summary of Unit 1, Lesson 7, No Bending or Stretching. Okay, today's goal is we can describe the effects of a rigid transformation on the lengths and angles in a polygon. So we have been dealing with rigid transformations for the past month, and now we're going to describe what happens to the polygon after you do a rigid transformation. All right, first the corresponding sides. Whenever you have two polygons, any pair of matching sides that are not in the same spot into different shapes, those are corresponding sides. So here we have our two shapes. Notice there the two blue lines. Those are in the same spot on the shape, but they are on the different shapes. Those are corresponding sides. These two right here at the top, the two purple ones, those are also corresponding sides. And I'm sure now you could identify more and more corresponding sides. They are on different shapes, and they're in the same place on this shape. Corresponding angles are similar, are exactly the same as corresponding sides, but now we're talking about angles. A pair of corresponding angles is any pair of matching angles that are in the same spot into different shapes. So here we have our two shapes. These are the ones we did in class. One is a rotation of the other one. And here you see those two orange angles. Those are corresponding angles. These two blue ones, these are corresponding angles. They're in the same spot on the triangle, but on different shapes. Okay, and the key points here of our lesson, each transformation that we did in our lesson that you were doing in GeoGebra, the lengths of the sides of the original figure are equal to the lengths of the sides in the image. So when we did the translation and we did a rotation and the reflection, the side lengths were the same in the original one and to the corresponding ones in the image. The measures of the angles in the original figure equal the measures of the corresponding angles in the image. So same goes here. When we did the translation, the rotation, or the reflection, the corresponding angles were the same measurement in both the image and the original one. Okay? These are called rigid transformations. So when you do any transformation and the side lengths and the angle lengths stay the same in the corresponding sides and angles, those are called rigid transformations. And basically they behave as if we are moving the shapes around without stretching, bending, or breaking them. So basically it's moving the shape in space, moving it around without changing the shape at all, just changing the position of the shape. All right, now here we have some examples here. Is this a rigid transformation? How do you know? So we have a reflection. Now here are some examples. These are all corresponding sides. So the colors that are the same are corresponding sides. The two red sides up here, these are corresponding sides. The purple ones are corresponding sides, and the yellow ones are corresponding sides. I didn't do the rest. And now what I want you to see is the corresponding side lengths are the same. So all the reds are 2. All the greens are purple. All the yellows are 2.4. And you could also see in the other ones that I did not color that those corresponding sides are also the same. Now let's look at the angles. So now here are the blue angles. These are corresponding angles. The red angles, these are also corresponding angles. And you notice that they have the same measurement. And if you check all the angles in the figure, you'll see that they all are the same as a corresponding angle. So this is a rigid transformation. Now we look at this example. Is this a rigid transformation? How do you know? Okay, so now here you see these two yellow sides. These are corresponding sides. AB corresponds to A prime, B prime. However, right away you can see that they are not the same size. So this is not a rigid transformation. Even though the corresponding sides are there, they are not the same size, so it is not a rigid transformation. Even though when determining that it's not, you just need to find one thing that is not the same, and it will not be a rigid transformation. However, for it to be rigid, all corresponding parts have to be the same. Okay, these transformations are called rigid transformations where all the corresponding lengths and angle measures in the figure and image are equal, these are rigid transformations. The three transformations that we have seen, translations, reflections, and rotations, are all rigid transformations. So those three, those are all rigid transformations. Okay, what are the three basic types? Rotations, translations, and reflections. These are all the rigid transformations there are. Yeah, these are all the ones that they are. If people try and tell you that there's other ones, they are just they're just combining these two. So if someone tries to tell you a glide is one, just say that's the same as a translation and a reflection.